In this conversion diversion nozzle, suppose this is the inlet of the nozzle and this is the outlet of the nozzle, and please remember this inlet or outlet, these are not real boundary or real inlet or real outlet. So these are actually the imaginary boundary only. That means we only for our convenience of study only we suppose we consider that this is the inlet and this is the outlet of the nozzle. Fluid entering into the system, the fluid may be water or steam, and this fluid is entering. That means the mass transfer is, this is the mass transfer entering, and technically fluid is going out of the system. This is also mass going out. So boundary walls are not insulated. That means there is no insulation. Then heat transfer, it may lose the heat or it may gain the heat from the, it may gain the heat from the outside also. That means heat transfer is possible in this case. So in such a case, this system may be considered as a open system. Now come to the isolated system. An isolated system is isolated from the surrounding by the this boundary isolates a system from the surrounding. So an isolated system is not influenced by the surrounding. That means surrounding has no influence on the system. So mass is fixed. That means mass cannot cross the boundary, and energy, it may be heat or work, energy transfer is not at all possible. Such a system is called isolated system. To summarize, we can consider all the system. That means open system, closed system, and isolated system. Let us take one example. Say some water is taken in a container and it is heated by some heating arrangement, and in this case heating means heat is supplied, and as a result of this heating the steam will be produced. If it is water, this steam will go out of the container. That means it is going out of the system. That means mass going out. So this is an example of an open system. Both mass transfer and heat transfer possible. If we close this, that means we do not allow the steam to escape from the container, then the mass will be fixed. That means no mass transfer taking place. Heat transfer is possible because we are actually heating this, so heat is entering into the system. So this is another example. This is one example of closed system, practical example. Now suppose this container, this second container is taken inside a thermoflux. So this is a thermoflux. So as you know, a thermoflux does not allow the heat transfer with the surrounding. So it does not allow. So it will remain heated. That heat, quantity of heat will remain same throughout the time, theoretically at least. So this is an example of no mass transfer, fixed mass, and no heat transfer, fixed heat. So this actually is an example of isolated system. But in practice, a isolated system is not possible. That is, it is not possible to make a system which is 100% isolated. It will always interact with the surrounding.